I'm going to take the time out to explain a very interesting um, thing I came up with about a year and a half ago concerning generators and electromagnets. Um, First off, I'm going to start off by saying uh, this is not a normal power generator. Um, what you see in normal generators, um, excuse me. Okay. So what you see in normal generators is this. Okay. This is basically a magnet, a simple magnet, and what happens is um, something, some type of power source, a crank, some type of pump, steam. You get steam engines. Something is going to get this magnet spinning. Okay, and I'm not going into the basic concept of eddy currents and how they work until we get to the actual generator. I mean, this eddy currents are a very basic thing. Okay, so at this point, you go back and learn what eddy currents are. Okay, uh, this spinning will produce eddy currents. Okay, and eddy currents perform electricity when they are met with the other half. Okay, so this spinning produces a current. Okay, going one direction. All right. Well, it depends on how this is taken. You will have um, a receptor right here, understanding energy, okay, and one right here, okay. And as these spin like that, this is taken up by this, and then I guess we'll do an eddy current. Eddy currents look something like this, okay, and this will go the opposite direction, okay. Okay. All right. All right. So what you will have here in a basic generator is things that form a car and things and stuff so of the sort. This spinning magnet, when it moves across a conductor, and a conductor is something that helps conduct electricity, electrons easily move through it. Again, I'm not going to inner depth of this, okay, but the metallic structure of a conductor, okay, copper, okay, the atoms in here and their electrons are easily movable by a magnetic force. Okay. Now this magnetic force, okay, that forms the eddy currents. Okay, this would be copper right here, and this would be copper right here. Okay, and excuse the poor drawing. I might have to redo this. Okay, one sec. So, so again, this is that verification. Okay. All right. Okay, so here you go. So just a little bit more. Excuse the drawing; it's sloppy. But again, say, so how power is produced? You would flip this magnet; it will start spinning. Okay, and usually first, first, before Tesla and all these other people came along, it would have one thing, one current traveling, and it wasn't north and south. They usually have it was called the DC generator. Okay, and the DC generator would basically pull power one way. Okay, all right. So I mean, it's always north or always south. An AC generator would be north and south. Okay, so the old phones, okay, traveled like this. DC is a direct current, okay, straight back and forth. Okay, so you would make a phone call, it would travel to that thing, all right, and then they would respond, and it would travel back. Okay, DC. This AC current is different. By the way, this, okay, would be an eddy current. Okay, this is traveling along copper wire. If you know what copper wire looks like when the magnetic current is going through it, all right, it's basically this wire, and the eddy current is swirling around it. All right, that's what it is. So one pole of this magnet swiping across copper, all right here, one pole swiping against copper force, okay, these electrons in here to move in a circular direction, okay, as long as there's one pole. That is a DC generator, okay, is only one direction. All right, now that is would be basic landline, you know, uh, phones and basic, things that they had before cell phones came out. Now this right here, AC, you would be using north and south, right? Okay, so instead of just going straight back, the wire, okay, it's the antenna, so you have on your phone, your cars, and everything else, all right, is basically two, okay? One's going up, okay, and one's going down, okay? Eddy current up, eddy current down. Now this vibration back and forth, okay, all right, is usually seen something like this, okay? That will be like a radio frequency that's traveling toward wherever it's going. So what you have is the antenna right here, okay, right? Then you have this magnet right here spinning with two receptors that are getting both sides of the electricity. Okay, so one is spinning up and one is spinning down. Again, there are many different antennas and antenna setups. I'm not going to get into that. This is an amateur video. I'm not the biggest nerd in the world, but this is not what this is. So again, right here, this going up, okay, and one going down, produce this up, down, up, down. AC generators are constantly switching. So with this antenna, okay, when you this power source, okay, and where it's coming from, okay, is using that magnet, okay, up here, all right, okay. Excuse the drawings and the sloppiness. All right, all right. So north, that's spinning, and through all the receptors and the amplifiers and everything, it hits up this antenna, okay, and it's going vibrating up, down, up, down, up, down. Now it's not. It's a lot faster. Okay, radio frequency to be a lot faster. Okay, um, it's more like up, all right. So that frequency would hit a phone. All right, it's your crappy cell phone right here. All right, we're gonna put the buttons all over the place. So I'm not sure. All right, hits the antenna of the phone. All right. Now we don't have those antennas on our phones anymore. We have chips. We have smaller things that's in there. Okay. Yeah, we don't have the laptop phones anymore. But this would hit this. It would vibrate, and then there's up and down. Okay, and again, they're not getting into all the things that are inside the phone that receive it, converted into electrical waves. I'm sorry, yeah, converted in electrical waves and then in sound waves. Okay, this would be air wave. Okay, electromagnetic. This is electromagnetic. All right, and it hits this. All right, currents more to electricity here, and electricity in here is converted into sound. They're all pretty much connected: sound and electricity and light and all that other stuff. And that's how it will go. Okay, so this is basically a child's. Um, so to people who do know, this will be a child explaining to experts um, what this is, and people who don't know, this is kind of strange. All right. Uh, so that's what that is. It's the AC. Okay. I'm sorry, DC is spinning one way. Okay. On one way landline. All right. Traveling through the wire. All right. Boom. Once we get this in antenna, this goes vibrates up and down. Okay. And this vibration radiates off of that copper. All right. And it travels to the most similar thing to it. Is you have different frequencies and how they travel and all the other stuff. All right, that's how this power is produced. All right, AC power is produced like that. All right, AC power has to be converted to DC power in a lot of different uh, places in DC, and also the other way around um, in order to form things. All right, so I'm not sure if there's anything I missed with that, but after that, there's very something interesting I figured out while figuring this stuff out. Okay. Um, and then the original idea came from a basic understanding of how electricity works with copper wire. Now, I'm not a genius. I learned this from other people, but it came from a basic understanding learning, basic building block learning of what this is. So I take the idea and moved it somewhere else, and I figured out something interesting. Okay, this isn't AC or DC. How to produce it? I came up with it. I haven't found anyone who has done this on the internet. Black, white, brown, blue, or yellow. Um, Now, the basic understanding that I'm talking about, you guys can go to the video and you can go look at this. Is I will write the video and the name of his in the description. But I believe this is something along the Nighthawk, Red Nighthawk. This guy with a beard, cool guy, smart kid, smart guy. Okay, he's just explaining what I just explained to you over here. Okay, all right, how to power a light bulb. All right, so the basically was that magnet you see. Okay, when you have copper and you sweat it along. Okay, now we're going to use different type of copper. This represents copper wires. Okay, all bunched up together. All right. This is be real quick. All right. Oops. All right. This would be a copper wire. All right. So it's real quick. You cut the copper wire to the light bulb. Again, things is all glitching on me right now. Okay. So what you could have here is a circuit, basic circuit. Okay. All right. And you could drop a magnet in here. And this is how the basic DC works. All right. Now, you drop this in here. A moving magnet produces what? Eddy currents. Right. So, right. And these eddy currents represent something. All right, and I found this out during the video. Okay, one's push and one's pull. You know, real simple. Positive, negative, push, pull. Okay, so as you drop this in here, all right, and then we're not focusing on which side, you know, does this and how this, why this is positive and how, you know, electrons are the ones always moving, and then you know, all this other stuff. Okay, what it would be is you would drop this, all right, and as you drop it, all right, from one direction, eddy currents are going to be pulled, okay, from copper. Again, copper is unique, and other metals are unique, where they have electrons freely flowing through them that can move easily when they come up against a magnetic force. Okay? So after that, you drop this in here. What this is doing, okay, as you drop this pull right here is pulling electrons. All right. There's this weird light bulb right here. All right, there you go. There's a light bulb on that. So as you do it, this is pulling electrons, okay, and one is pushing, okay. So it will be, okay. So you just drop this in here. This, and again, eddy currents only go on one direction. One pole goes one way and one goes the other way. So this is going to push constantly as it's falling electrons through this copper wire, okay, and this is one that here is constantly pulling them, okay, all right, and as it's falling, this push, okay, pushes the electrons, and you light up this light bulb, and this is pulling it, and it helps keep it going. And once it falls through, it's over. All right. So this is where the idea came from what I am trying to explain to you right now. Okay. Now, what I came up with is something called, I like to call, repulsion technology. Okay. You would use number one, you would have a conductor, a bar. All right. All right. You have this conductor. All right. And you would have magnets right here. All right. In the inside. So this would be like a tube. Okay. All right. So on the inside, you could have magnets, but see, this magnets is going to do something different. Okay. See, this DC, a moving magnet produces an eddy current. Okay. It's not the magnet that's moving; it's the magnetic force. Okay. That comes out of it. Okay. That brushes up against the copper and makes it move. Okay. It's the magnetic force, not the magnet itself. Magnetic magnet itself. Okay. So what you have here, okay, south and south, all right, with a conductor, something that conducts electricity, right here in the middle. So we'll put iron, all right. So what you're going to have here, like again, I just explained to you, is a magnetic force that forces uh, the copper to move. Okay, all right. So what you would have here is two repelling magnets. What these would do is they repel each other, and a magnetic force, think of it as a bubble, they go up against each other and they react within the iron. You understand? So they're repelling each other with the iron. There was another video by Nighthawk where he actually showed an repelling. Um, he was repelling a magnet. What this would actually look like. So if you hold this magnet underneath this one, underneath a conductor, this one will start floating. Okay, and it will start floating in a circular direction. Okay, and based on which one it is, north or south, that's the eddy current. Okay, it's spinning while it's flowing. It's an eddy current. Okay, it's one pole. All right. So as these repel, all right, in this conductor, because we know that a moving magnet, okay, or the movement magnetic force, since these are constantly repelling, this is wedged in there. It cannot escape, okay? All right, it's stuck. All right, so this on this side, they're repelling, but if you hold two magnets together, they're constantly repelling, okay? As long as you have something to keep them, they're constantly repelling. So this right here will produce an eddy current, okay? Push, pull, whatever you want to call it, okay? All right, this, all right, will actually spark these things in here to start spinning in that direction, okay? Now, this bar out here is also iron connecting electricity. This spinning is also going to help produce electricity. Now, these magnets, you always need moving magnets to produce electricity, but these technically aren't staying still. The magnetic force that is constantly being repelled against the the iron conductor, okay, it's constantly doing it. It does not stop, okay? When you hold two magnets together and you keep them holding together, they stay repelling. They do not stop, okay? They always repel. They don't just decide, okay, magnetic force is done. We're done repelling each other. No, okay? These are always repelling. This is always being produced, okay? Right here. You understand? As long as there's something right here to hold this right here, this is always being produced. This is one side of the pole, okay? The push-pull, all right? I'm not going to get to on which one push and which one pulls, but this is what this is, all right? Okay? So, you go further. You have more iron right here, all right? Now you hit the center of the magnet, all right? So, this would be north, okay? This is going to be different than what this is, all right? This would be north, and there's going to be two sides of a magnet, or, I'm sorry, to find magnets like this is pretty hard. Um, this is not iron. Yeah, sorry about that. Okay. So this is not iron. This would be this. Okay. From the North Pole, a magnet. Okay. So this could be negative on the outside, which is not really producing anything because it's not being repelled. Okay. And this right here, okay, excuse that. All right, would be a magnet south north. Okay, and then the north is right here. All right, and then this north, okay, will be reacting with another magnet. Okay, it'll be south. All right, excuse me, 1 second. Okay, so this is a fuck up. Excuse the language. This is not how it's supposed to be because it looks ugly. I don't want to do it that way anymore. So let's review that. All right. So let's start from right here in the middle. Okay. North, south. Okay. All right. So now These would be two separate magnets. All right. Again, this is still valid, and this is still over here. All right. So that's how it would be. Okay. All right. So this is repelling with iron conductor. Okay. So that's producing an eddy current. Okay. Then it goes to this. All right. The other side of the magnet. All right. This right here. Okay. Is supposed to be the center. This is what keeps this thing going. All right. This is repulsive technology. Something I came up with. It might be maybe childish and baby Google, but I got to the experts, but it's something interesting I found out. All right. All right. So these two repel again. Now right here, all right, you would have north, and this is south. You put another magnet right here. Okay, so this would be one right here. All right. All right. And this is one as well. All right. Now over here you have north iron. We're gonna get to that in a second. Okay, another north, and they're doing their eddy current thing down here. All right, going the opposite direction of that one. Okay. All right. All right. And then south, right here. All right. So right here, we have two poles being produced, like an AC. Right here. Right here. All right. This is what forms two parts of a magnet. All right. Now there's a little shindig that's going on right here. Okay. These are constantly being repelled as well. All right. See this right here? This is constantly repelling with this, and this is constantly repelling with this. North, north, south, south. Okay. All right. Now, there are a lot of different understandings of how magnets work and how magnets work. Excuse me. Gross. Flu season. Um, yeah, coronavirus. Um, where okay, so yeah, this is constantly producing one, right? And this is constantly producing one, all right, on the other side. Now, these things are attracted to each other, all right? If you look at a battery, okay, the battery has plus and negative, okay? Now, these two are always trying to find each other, all right? There's things in the middle, which represent this, okay, that keep these two from touching, and once you connect this to a wire, okay, okay, these negative electrons will always try to find somewhere to go, okay, and these will always try to look for electrons, period. All right, and that's how you form a current. All right, so that's what we will have here, because it's basically a buildup, okay, of electrons and a lack of electrons right here. Okay, you connect a circuit and voila. All right, so right here, all right, you have the center. All right, these two eddy currents no longer, okay, are two separate things. All right, and there's a very, I was a reference to a very intelligent man, their apophasis. God is smarter than a lot more engineers. Um, the way a magnet works isn't exactly north and south. Okay, these things exactly aren't moving opposite directions. Okay, so okay, all right. My video is about the storage is about to go, so I'm about to clean this up. Okay, so these in a center are going one way. Okay, and people need to understand that. Okay, it's just when you go out further. All right, all right. You go out further, they seem like they're going different. All right, but if you sit right here in the center and look left and right, they're both going and doing the same way. All right, all right. He's spinning, not spinning that way, and he's spinning that way. These two, these two things are going and forming one. Okay, all right. So when you have magnets that are attracted to each other, all right, you have this and you have this. Okay, one's not pushing, one's not. This is a deeper understanding of magnetism. One's not pushing, one's not pulling. What happens is these two, they won't be eddy currents at this level. It's magnetic. What they are, okay, they just are attracted to a center. Okay, all right, and then that center literally is what these two are together. All right, so if you put this on an electromagnetic scale, okay, and these two, all right, are constantly forming that, okay, and these are constantly forming that. What's happening right here in the center, all right, is this is going this way,